Hello and welcome to today's math lesson. So today we are going to be continuing with chapter 7, but I thought you might want to just pause this video right now and give these Wuzzles a chance. So go ahead and stop the video and see how everything is going here, or if you guys can fill these out. And you're back. All right, this first one. What can it be? Well, you can see temperature is kind of falling or dropping. So some people say fall in temperature or temperature dropping, something like that. So it has something to do with the temperature dropping or a fall in the temperature. All right, the second one going across is kind of a gulf thing. And if you look at this 2, it's under the par. So this is 2 under par. That's a golf terminology. So let's just say you're on a par 5. 2 under par means that you took 3 shots to get it in. All right, this next one's a little tricky because it says chance. And if you look at those letters, look at those letters compared to all the other letters, mainly here in that first row, and they're a lot bigger, wider, fatter. So there's a saying that kind of says fat chance. And that's what this is signifying, is fat chance. All right, the next one here is either heartbreak. I can't remember what the other one people cracked heart. No, heartbreak is the one that typically comes up. Okay, the one in the bottom middle, if you look under hot, and hot again is under. So this is hot under the collar. Hot under the collar. So this is usually if someone's angry, or you could be describing someone, oh yeah, I was talking to my friend, blah, 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 and they were hot under the collar. So meaning they were upset with what was going on. And the last one means something like your head's in the sand. So don't bury your head in the sand when something's going on, and you should be a part of it in some way or form. All right, hope you enjoyed these Wuzzles. And now we're going to continue on with special parallelograms. So what we've done in 7.1, 2, and 3 is talk about all the properties that parallelograms have. And remember, there are 6 properties that they have. So both pair opposite sides parallel. Both pair opposite sides congruent. Both pair opposite angles congruent. Consecutive angles supplementary. The diagonals bisect each other. And then we also had one more that we talked about, is one pair of opposite sides congruent and parallel. One pair of opposite sides. So we had 1, 2, 3, 4, 5, 6 different things that we were studying. So those are all properties of parallelograms. Well, now we're going to classify those parallelograms. So animals aren't just animals. Some are vertebrae, some are invertebrate. Okay, so we have different classifications. And so what we're going to be looking at today are special parallelograms. And many of you can be thinking right now of some different special parallelograms and where they fit into things. So we've been studying the polygon. Then we talked about in the polygon, we can have a quadrilateral. Well, now if all those properties happened, we had a parallelogram. Well, you guys probably also know these other 2 red and blue words in here. So what makes a rectangle? And the definition of a rectangle is a parallelogram. So first and foremost, it must be a parallelogram with 4 right angles. So the definition of a rectangle is a parallelogram with 4 right angles. And then the definition of a rhombus starts off with it has to be a parallelogram, and then it has with 4 congruent sides. 4 congruent sides. Now, if you put those two things together, that you have a parallelogram with 4 right angles and 4 congruent sides, then you're going to end up with a square. So a square is going to have the properties of both the rectangle and the rhombus, which has all the properties of a parallelogram. Okay, so now we're going to go forward and we're going to give some different properties and conditions of these quadrilateral polygons that we have just now named. Okay, so let's look at the shape of this blue figure in here. And I'm going to end up erasing here, but the parallelogram, you can see that the both pair of opposite sides are congruent. All of those things hold true for the rectangle. Both pair of opposite sides parallel, both pair of opposite sides congruent, both pair of opposite angles congruent. The diagonals are going to bisect each other. Well, what else do we notice about here about this diagonal and this diagonal? Okay, not only are they bisecting each other, but are all 4 of these congruent? So if they are congruent and bisecting these diagonals, then that is going to be a property that happens with the rectangle. So in your rectangle, you're going to have both pair of diagonals are going to be congruent. All right, let's see which comes up in here. So your diagonals are congruent. Okay, and then if we have a parallelogram and 1 right angle, then it is going to be, 1 right angle, then it is going to be a rectangle. Now the definition does say a parallelogram with 4 right angles, but if you show and you absolutely know that it is a parallelogram, and we say, hey, this is a right angle. So we're telling you this is a parallelogram, and we're telling you you have 1 right angle, you can now conclude that it must be a rectangle. All right, going into the red figures, these are all rhombi, rhombus for singular. So if we have 1 pair of congruent consecutive sides, remember, this is a parallelogram already. So if we tell you that you have 1 pair of congruent consecutive sides, remember that implies that the opposite sides are now also congruent because it is a parallelogram. So now we conclude this is a rhombus. All right, the diagonals. If I were to draw in these diagonals here for you to see, whoops, I erased something there. What happened? So if I draw in this diagonal and draw in this diagonal, we would be doing this as an experiment, but you can see very closely here, if you were to put a piece of paper in here, these diagonals are perpendicular to each other. And they also bisect so that this is congruent to this, and this side is congruent to this side. Not all 4 of them are congruent, okay? But if they are bisecting each other and perpendicular, then we are going to have a rhombus. All right, and the last one here. The diagonals also bisect the opposite angles. So when I draw in this diagonal right here, this is bisecting this angle. So if I know this is 20, you know this is 20, you know this is 20, and you know this is 20. Okay? And then going across this way, this diagonal would be bisecting this angle. Okay, not all 4 angles are congruent. That is not what's happening. But the diagonals bisect those opposite angles. Then we can conclude that it is a rhombus. Now, if they have all of these properties of the rectangle and the rhombus, then we are going to have your square. Okay, so if the diagonals are going to be, so we draw in this diagonal and we draw in this diagonal, whoops, that didn't go very well. They are going to be perpendicular and they are all going to be congruent. They're also going to be bisecting, so we know that all of these are 45-degree angles, and we know that this is 90. All right, Okay, so you might need to go back and revamp and write down all of these properties. Now we're going to practice using these properties. So decide in this if it's sometimes, always, or never. And they're telling us that this is a rhombus. So angle Q and S, they are always congruent. Always. Angle Q and R, sometimes. QR and RS, always. If Q and R are going to be congruent, they're consecutive, we're actually going to make this into a square. So if they would be consecutive and congruent, then it's going to actually be a square. But we can also say that a square is a rhombus. We just can't say that a rhombus is a square. All right, is this quadrilateral? Can we say that this is anything specific? Now, is it different if we put this word quadrilateral here, or if I put this word parallelogram here? If this is a parallelogram, I know now that this side is congruent to that side and this side is congruent to that side. So now, do we know for sure that this is a rhombus? And the reason they specifically told us that's 80, because if that was 90, then we could be even more that it's a square. But this one right here, just saying it's a quadrilateral with this, we cannot. It is plain and simple, just a quadrilateral. We cannot go any further than with that, because I have no idea if these opposite sides are congruent. All right, find all the measures of the numbered angles. All right, if this is 61, then remember this is 61, and this is 61, and this is 61, because that diagonal bisects all of those angles. Now also remember that in a rhombus, your diagonals are perpendicular, so this is 90. So now if we take 90 minus 61, we are going to get the measure of angle 4. So 90 minus 61 is going to give us 29 degrees. All right, there are numerous ways that we can do this, and they want you to give all names that are applied. You need to prove, when you do a problem like this, your math needs to be able to prove whatever it is you are trying to get to happen. So you could do the slope of AB, and the slope of AB is up 1 over 1, 2, 3, 4 is 1/4. And the slope of DC is the same thing, 1/4. So we have opposite sides parallel. The slope of AD and the slope of BC, so this is up 4 over 1. So this slope's 4, this slope is 4. We know for sure that we have a parallelogram. So now if you have a parallelogram and we can get the diagonals congruent, we know for sure not perpendicular, so no perpendicular lines, so not a rectangle or a square. We know that for sure just from doing this. So to get this to be a rhombus, we now need to get two consecutive sides congruent. So you're going to have to do the math and find the length of AB. I'm running out of time, so I'm just explaining. AB is congruent to, and do a consecutive side, so either do AD or BC is congruent to AD. Do the math to show that, and then you can conclude that you have a rhombus. Okay, so first I showed that it is a parallelogram, and then it is not a rectangle or a square because we do not have any perpendicular lines. And then you'd have to show consecutive sides being congruent, and then you can conclude that it is a rhombus. All right, the last thing, I'm going to be running out of time here. So answering these questions, if you stop and freeze it, you will be able to come back and answer them. So will a diagonal of a square ever divide it into equilateral? No. This side will be congruent to that, and this one will always be bigger. In a rhombus, yes, it could happen if we have 60 degrees, because now these are 120. So when the diagonal comes down, it is bisecting. So this is equilateral. All right. Good luck on your homework, and you can freeze and answer these.